Okay, so we're going to go through some of the steps you're going to need to do for Lab 4. And this is going to be a combination circuit. So we're going to look at this, first of all, get the parts already we need. So I want you to make a couple of these little hoops, and we're going to use those to give us a clean, solid spot to connect our positive and our negative power. Then we're going to need 4 or 5 little jumper wires that we're going to be using to make our measurements using the clamp-on meter. And then we're going to need the usual suspects, the 33, 47, 51, 82, and 100 ohm resistors. I'd also like you to take out some LEDs, and I've prepped these. So with an LED, it's a polarity sensitive device. It's only going to work in one direction, not both ways. So what I'd like you to do is there is a longer lead and a shorter lead. And the shorter lead, it's like they subtracted some took the 2 long leads and cut one. So the shorter lead is our negative and our longer lead is our positive. And what I usually do, just so before I install anything, I bend one of the 2 leads so that it's like, kneeling to power type thing. I know that this is my positive, and when I put it in, I make sure that the longer bent lead one is closer to the most positive part of my circuit. So those are the parts we're going to use, and we're going to start arranging our circuit as required. Alright, so let's start by taking these little loops, and I'm going to insert one on my positive rail, and I'm going to take the other small loop and I'm going to put it in my negative rail. And what that will allow me to do, and that's settled in nice and tight, when I go to connect the power supply, I've got somewhere it's going to make a good clean connection. If you've watched some of the other videos I've done this before, so this should be old hat for some. So this is going to give me power from my power supply, which I don't need right now, but at least I know I have my 2 markers or connection points. These little hoops on this particular breadboard, for example, this is not continuous, so this provides a jumper to it, but these can be quite handy for test points. So if you're making a circuit, you can use a small jumper just so that you can get your meter to check it really easily. So the next thing we're going to do is we're going to start installing the resistors, and I want you to do it in a particular way, which will be in the next segment. Okay, so I've got the 5 transistors, 33, 47, 51, 82, and our 100 ohm resistor. Now I want you to make sure that on the ones that are going across the moat, that you have a couple of extra spots open on the top. So that's about the 3rd column in. Oops, guess I should do as I suggest. Missed that one. And I have a couple of extra spots here, and this is going to allow us to put some jumpers in and make some connections. At the other side, towards the negative rail, I've got 2 holes set aside, so we can use that to do the next phase. Now, what I'm going to do is, as a method of just checking to see that my circuit's going to work, I'm going to use these LEDs. So when I go to set it up and turn it on, I'm going to put the negative on the blue bus and the knee to the power on the same row as the LEDs. And when I'm finished, there should be these 3 lights should light up like a traffic signal and let me know that each of my branches is working and performing properly. It's as I build it, that way it's I know right away that I have a working circuit. So the next thing we have to do is we have to put in our jumpers. Alright, So we've got the basic layout. Now we have to start supplying power, etc. to it. So the first one, of course, we're going to do, we'll take a red lead, and we're going to go from our power rail, and we're going to go to the hole closest to our resistor. And then we're going to take the next lead, and that's why I'm giving you 3, so I can connect that to our next resistor. And then from our next resistor, we're going to jump to the next one. Now at this point, you're going to need to do this all the way along. And these loops are big enough that I can get a clamp-on meter to go through. This one might be a little bit small, but these other ones I should be able to, if I don't get it through the resistor itself, I should be able to get it through the wire lead itself. These ones across the moat, they should be wide enough to put your finger. If you can put your finger through that, you should have no problem getting the clamp-on meter to work. So you just finish off completing the loops so that all of these are connected, and when you do that, that connects each of these branches. And right now we're using these LEDs to finish off to our negative rail. Okay, so I've got my loops in. Now one of the things I had to add, because I didn't have enough the small wire, if you get into this as a hobby or that you want to try something out, there's lots of places you can purchase what's called a ribbon cable, and that's all different colors, and they come in different formats. This particular one is male to male, and what I did was I stripped a bunch of them apart from each other, so I have a bunch of these quick disconnects, and they can come in male to male, female to female, or male to female, and they have different lengths. You can get quite short ones or you can get long ones. If you ever get into the Arduino series and you get a starter kit, they often come with a small bunch of these because you'll use these quite a bit. So this just, I have this just plugged into our circuit, and it fits nicely in the circuit board, and I've got a great big huge loop if I wanted to use that for measuring. Now with my particular meter that I'm using for this demonstration, it is not a clamp on, so I'm going to show you, because there is a time where you're going to be able to have to use one of these meters to put the meter into the circuit. At the same time, I've actually got my thermocouple and thermocouple adapter ready to go, because we're going to do this circuit and work it through, but we're going to use call it an alternative universe, and what we're going to be doing is we're going to be switching these around. The biggest part of this exercise is not simply that we're going to calculate the loads and we're going to calculate the current flow, etc. That's true. That's a key fundamental skill. But in the bigger picture, this is all my positive, and these could be considered like the black wire in a house. This could be considered all my power wire, and this blue rail could be considered the neutral. So when you're doing a circuit and it can have 12 receptacles on it, each of these would be like a load going across, completing the circuit. Could be a light bulb, could be a vacuum cleaner, could be a hair dryer. All of these different things could be on the same circuit, and eventually you'll end up drawing more than the allotted 15 amps, and you'll pop the breaker or blow the fuse. But as you're going through this, you'll see that the currents start changing and going in different directions. And if you're doing fixed loads, you may have to rethink the way you're wiring it up, or it's just important to understand what the loads are and how they're impacting your circuit. It's not static, especially when these are receptacles and you're constantly moving loads back and forth. So what we're going to do now is I'm going to turn on the power supply, and I'm going to make the connections to the power supply. Alright, so I've got my circuit complete. I've got my power supply set to 5 volts. I'm going to connect the negative side, and if I've done everything right, these should light up like a Christmas tree. So that tells me right now, maybe glaring, but it tells me right now that my circuit is working fine. So what we're going to do is, I'm going to put that back and I pulled it out. You can now, once you've done that, that gives you the troubleshooting tool that you know that your circuit works. That if this light did not come on, then there's something wrong here. If this one come on, it's kind of an instant check. Now you can leave these in there. It's not going to impact the circuit terribly, but there is a small voltage drop that each of these will create. So I'm going to take these back out, and I'm going to move my connection to the negative rail, because I know that my jumper situation over here is fine. It's doing its job. So I'm going to move that back, and I'm going to put the connectors through here. And when you go to do the next part, you're going to be measuring the current. Each of these, as we know, should in theory be the same voltage drop, but we're going to check that because this resistor and this resistor act as a load, acts as a voltage drop, and we're going to take a look at each pattern as we go through. When we're starting off with 5 volts, we can measure that. So I'm going to put my turn my meter on to volts. I'm going to get my 2 leads. Now I've got the particular version that I ended up getting. Oh, this is on. This is not on the correct one. This is on Surfer Dude. So now I'm on Dead Man on a Gurney. Perfect. Okay, so this one here, this has got a threaded attachment, and it's got the lead's got a threaded attachment, and it came with these alligator clips, which is actually quite a nice feature. So I'm going to use that to my advantage, because I have to, when measuring current or voltage, it's fine. It's when I start to measure and get into the current, I have to do it a different way, and you're going to get it easy because you just need to use the clamp on in the different locations, whereas I have to insert my meter into the circuit. So I've got my negative connected, and I'll take off my clamp here and plug in my positive. Okay, that's good. And I want to set that up so you can see that a little better. Not in the glare of the light, but it's still enough to be able to see it. If you turn on the background light, then it gets washed out. It's one of the drawbacks of trying to make videos with a certain amount of lighting. You're a cross between reflection and non-reflection, so doing the best I can under the circumstances, I can get that to be in a position where it's on an angle and you can see it and not have the glare of the light, then I'll have done my job. Oh, that's pretty good. Okay, so what we're going to do now, I'm going to put the 5 volts back on. In fact, on the fly editorializing, I'm going to put this on the other side so it's not going to be interrupted. That works perfect. Okay, thing out of the way. I'll put my power back on. So I've got 5 volts applied. I've got my meter set up, and I'm set up on DC volts. So I can first of all check my overall voltage to see what how many volts the system's producing. And I'm putting my right lead untangled in my right hand, red lead in my right hand, my untangled black. Okay, so I can put this here, and I can put this here and check across. And right now the power supply says that it's, even though it says 5 on my power supply, I'm only getting 4.7. So I'm going to crank that up just a little bit. I've got 5.3 showing, and here I'm receiving 4.99. That's really, really close. A little fine tune. Too much. helps if I actually get it on the device. So 5.01, if I can get that to stay, I can then drop this down 5 volts. There we go. Alright, so I've got 5 volts applied to it. So each of these are going to be a voltage drop. So one of the quick ways we can figure that out is see what the voltage drop is across our first load. And it's 4.98, really close to 5. Let's go to the next one. It's a parallel circuit. You would think, oh, that's going to be 5 volts. But then when you put this on here, we've dropped down to 2.25 volts. So there's a lot of voltage drop created by this particular resistor. And if we go to the next one, we find it's only got 1.24 volts. So each of these are not significant, but they're significant enough to really drop the voltage. So what you're going to do is you're going to measure the voltage drops against all of them, and your numbers may not be exactly the same as mine. So you've got to verify that. And you may ask, well, yeah, it should be the exact same. Well, the length of my jumper, that's a resistor, that's a resistor, that's a resistor, that is. The back plane across the breadboard, it's nominal, but it's still, every time we've done that, it's put a small bit of resistance into the circuit. So you're going to measure the voltage drops across every single resistor in all formats, and then we're going to start looking at the current. All right, so because I'm using a regular handheld digital multimeter, I'm not using a clamp-on meter, I have to take this meter and make it a part of the circuit. It's going to end up being one of these resistors in essence. And because of that, I have to be on the right setting. If I'm not, well, it can be disruptive to the meter, as we've talked about, and it can also be unsafe for yourself. The other thing to keep in mind is while I'm working on this, if I open up any of these wires, I become part of the circuit. As I mentioned in the class, there have been electricians who have been killed because they were changing an amp meter. And they thought the power was off, they thought they were all right, and they ended up becoming the circuit. And basically, from your left hand to your right hand through your heart, you're a 200 ohm resistor. If the conditions are right, it can be less. If it's a hot, sweaty day, etc., there's all kinds of factors and stuff. So that's the last thing you want to do. So what I'm going to do is, the first thing is I'm going to adapt my leads so I can actually put this meter into the circuit. And as I said, this particular model happened to have these thread-on alligator clips. So I'm going to make sure this is pushed back so I can actually reach it on the inside. And this says I have a maximum of 1000 volts, category 3. Okay, so I took the sheath off and I replaced it with this sheath. So it puts me back up to my category. And that's my other one. Good. All right, so now what I've got to do is I've got to take the circuit and open it up. So I'm going to turn off my power. Don't want to work hot. You should not work with hot. Here I understand that the voltage and the current are very small. Don't get in the habit of working live. It's unsafe, it's dangerous, and it's against the law. Simple as that. Okay, so what I'm going to do now is I'm going to open up the first part of my circuit, which is this set of jumpers here, and this is probably the trickiest one because I've got to get from here, back into my circuit. So I'm going to grab another jumper wire, and for you it's going to be simply a matter of using the clamp-on meter. But I'm going to open this up and put in another wire, so I've got the power will be coming through this wire, through my meter to this wire, back to here. So I'm going to take my red alligator clip and I'm going to put it on the most positive part, which is that first red wire. Okay, that's alligatored. And then I'm going to take the black one and I'm going to put it on the other wire. So now I've got my circuit goes from the wire through into my meter, back out my meter, through the black wire, and then feeds my circuit. So now I can turn the power back on, and we can see that my meter has leapt into life, and it says right now I've got about 97 milliamps. So that is the amount of current that's going through our system. Now for you, it's really simple because you just need to use the clamp on meter, and you should be getting somewhere around there, but not exactly the same number. The next part I've got to do, and again, this is a real pain in the derriere. I've got to turn the power supply off, open up this lead, open up this, restore this into my junction point. Now I've got to open up my junction point, put in my red jumper, and then I've got to now put the meter in through the resistor. So I'm going to take this, clamp that onto my lead. I've opened the circuit. This rest of the circuit hasn't changed. It's just this one particular load. Now I got to take my black lead and I'm going to put that on here. So again, we're going from the circuit into our meter, back out of our meter, and completing this branch. The rest of the circuit has not changed. Power still goes through here, goes through this resistor, it tees off, drops this way, and again finishes our circuit. So now I'm going to turn my power on, and this particular one says this particular branch, just by itself, going through this resistor, this 33 ohm resistor, is about 94 milliamps. Okay, so I'm going to turn my power off, and I will have to do from my working with the feed, I would have to go through every single one of these points to break it open and insert the particular jumper wire and lead. For you, it will be significantly easier. Now, when you go to do these ones here, because of the large size, if you trim these to be close to the deck, which is understandable because I believe I mentioned that's the best way to do it, to seeing it. If you haven't got the room, then what you're going to do is you're going to create another small jumper, and this is why I suggested leaving some space, because you can then get a larger jumper. And in this case here, this one's really super easy. You just move it close and it's going to do the same thing. But for these other ones, you're going to install a loop that you can actually read. So if this doesn't work, you can't get into there, you'll have to put a longer lead. For this load, it's really easy. If not, again, you're just going to insert a jumper between those 2 points so that you can actually read it. So I put this over here, for example, go to here, and presto. Now this is redundant in this case, but the same thing will apply for there. So after you've done that, you're going to record all that. So I'm going to take this apart and we'll show you what the next step is. Okay, so I've redone my circuit, and I've shuffled some of the deck chairs on the Titanic, and I've moved them around so that the currents will be different than the original outlay. So this used to be the 33, 47, 51, 82, and 100. Now I have the 100, and just to make sure I've kind of got them where I want, I've flipped the tolerance bar so I'm looking at it in the right orientation. So this here is our first, it's our 100, then we have our 82, followed by a 47, 33, and 51. And when I look at my current reading, I'm getting 97. And if I were to move that to the next spot, okay, I'm going to take that. We've got the power going to there. I'm going to put that back, turn the power off. Okay, open that, put that back. So that was the total current. Now I want to open up just this first resistor and yet keep the rest of the power going. So for me it gets even trickier. So that's going to keep the power going that way, but I still need to provide go-go juice to the first one by its little lonesome. So that's all by itself, but it's part of the same network. Power's got to go in. It's coming through there. That's those two are parallel. That'll work. Okay, I'm going to put my most or negative there. See if I got this correct. Maybe not. Things happen. Get tired, old. And this says I'm drawing 95 milliamps just through this one resistor, and we had 97 total. So that would suggest to me we've only got 2 going the other way. Okay, let's turn the go-go juice off again. Open that up. Open that up. I'm going to restore this to its pristine condition. And I've got power coming in from the supply in the back plane. So now I can open this up. And this is going to give me the current that's going to be flowing not through this resistor but through the balance of my circuit. Okay, that's going to go that way and that way. Connect that up. Okay, turn on my power supply. And I've got 97 ohms flowing through the balance of it. So as you go through, you're going to do your readings, and you're going to you don't have to open up the circuit. You just need to put the clamps just like you did before to see where the different current drops are. And when you've done that, that's going to be under section 3 under the alternative universe. And you're going to record all your currents and measure your voltage drops. And the same thing, what's the voltage drop now across here? What's the voltage drop across here? Because this is a series circuit now, so I need 2 different voltage drops. I need the voltage drop here, etc. And after you've done all that, you've pretty much done a combination circuit. Alright, now the next step is going to have you tear this apart and reorganize it. And it's got a different layout of the resistors. You're going to swap them out. But before you do that, before you even contemplate it, what I want you to do is to use the thermocouple that came with your meter. So you'll need the adapter and you'll need the actual thermocouple itself. And part of this is so that you can continue to practice using it, because you might have tried it once. But the other part of this is that these resistors under load will start to heat up. And this will tell you whether or not the heater, the thermocouple itself, I haven't got that plugged in. There we go. Okay, so right now my ambient temperature and old stuff is Fahrenheit, which is what I'm used to. But I'm going to turn that to Celsius. Okay, so it says that right now it's 19.5 degrees where I'm doing this. And if I touch that on here, that says that's at ambient temperature, which is good. If you have it under the right conditions with a little more voltage, I think in the last lab we actually turned up the voltage. So I'm going to crank this up just a little bit. So I'm now at just under 8 volts. Give that a second. That one seems to be okay. So going up to 7 volts hasn't impacted me too much. Let's go up to 10. I'll make it 12. 12 volts. Well, these are happy as a lark. But I want you to just to make sure that these aren't getting to the point where you can burn your fingers. And just doing a quick check, it seems to be pretty close to the ambient temperature. Now I can prove that my thing's working by squeezing it. And unless I'm clinically dead, it should start to climb. Got that in right, got that in the right polarity. should be climbing. Unless I've damaged it. It's entirely possible. When you're packing and storing these, if this solder joint gets broken or somewhere broken inside, it may not work. Yeah, it got warmer than that. Call the morgue. Interesting. Anyway, that's what your I want you to do that just to make sure that these aren't going to burn you when you go to swap them out.